All right, so section 415, like I said, they call it dividing polynomials. Some people will call it long division. It just kind of depends on who's teaching it. Like I said, dividing polynomials seems to make the most sense because we're not just going to do long division for all of these problems. Some of them, it's just division. Okay, so look at questions like number 1 and 2. Notice how we're just dividing by x squared. Right here we're just dividing by b squared. Right here we're dividing by 4p squared, but it's just a single term. But then all of a sudden we start dividing by r minus 1. Right? So that's a binomial. And a 3k plus 1 and a 3n plus 2. Right? Not just a single term, but we start dividing by two terms. Right? So that's when we talk about long division. But first, let's go up to these original 3. Okay? Now, I'm only going to show you how to do one of these because since there's 3 of them, if I do 2, that means I've done almost all of them. Right? I got to at least let you practice 2 of these on your own. But then I'll go over more of the long division, which I think you guys will appreciate anyway. But let's take a look at this really quick. We'll work on number 3. Okay, so let's look at number 3. The trick to doing these problems is that you break it up. Okay, so I'm going to rewrite number 3 in a certain way here. 8p cubed plus 8p squared plus 4p divided by, notice how it says divided by right up there, and then by 4p squared. Now, I know it doesn't make it look a lot easier, but what I'm about to do right now is break it up into 3 different fractions. You notice how the numerator has 3 terms, right? 8p cubed plus 8p squared plus 4p. It has 3 different terms. That means I can break this up into 3 different fractions. Okay? So, this is going to be 8p cubed divided by 4p squared plus 8p squared divided by 4p squared. Notice I'm dividing these 2 terms, then these 2 terms, and then these 2 terms. Okay, so I'm going to put plus 4p over 4p squared. Now this is to do it, I would say, the easiest way possible. So now, look at the very first fraction that we have, okay? The very first fraction that we have right here, 8p cubed divided by 4p squared. So 8 divided by 4 is what? 2, right? So I'm going to write 2. Now, p cubed divided by p squared. P cubed divided by p squared. You guys remember the trick to dividing common bases with different powers? If you don't, let me give you a real quick reminder. This is a formula you guys learned in Algebra 1. That whenever you divide by the same base, the base is the big number or the big letter, and they have different powers, all you got to do is keep that base but subtract the powers. So notice p cubed over p squared, that's 3 minus 2, right? What's 3 minus 2? 1. So I'm just going to write p to the first, which is just leave it like that. Okay. Plus, now, 8 divided by 4 for my second fraction, that's 2 again. What's p squared divided by p squared? It's p to the what? Well, 2 minus 2, which is 0, right? 2 minus 2 is 0. What's p to the 0? What's anything to the 0 power? Not 0. It's 1, right? Yeah, anytime you raise something to the 0th power, it's 1. So we'll put times 1 plus 4 divided by 4. Well, that's a 1. And what's p divided by p squared? Now notice, that p has a power of 1, right? That p has a power of 1. So 1 minus 2, negative 1. Okay, so let me rewrite this so we can be done. 2p plus 2 plus p to the negative 1. What do you do with negative powers? You guys remember? Where do you place them? You guys remember moving them? In case you don't remember, let me remind you here. If you get a negative power, you kind of flip it to the other side so it becomes positive, right? So it goes down to the denominator. In other words, this ends up as 1 over p. So which one is my answer from A, B, C, or D? A. It's A, right? So here we go. Now these are considered, some people say these are the easier ones. I actually prefer long division over these, but a lot of people say these are easier for them. Okay, so all you have to do is break it up. Okay, so just to kind of show you, like for question number 1, you're going to want to write 2x to the 4th divided by x squared plus 2x cubed divided by x squared plus 2x squared divided by x squared. That's going to be you breaking it up. This one right here, to break this one up for number 2, you're going to write 2b to the 4th divided by b squared plus b cubed divided by b squared plus b squared divided by b squared. Okay, so I'll kind of show you one, but I'm not going to do it. But just so you can see, this one, when you do this, you're going to want to write it out like this. You can finish this up, but I'm just going to start it for you. And then the last one, you're just going to have to do all on your own. But that's the way you break up number 1. Okay, into 3 different fractions. Okay, you'll do the same thing for number 2, and then just simplify it. Okay, simplify it from there. Remember, these notes I'm going to be sending them to you guys, so you'll have this. Oh, by the way, right now that I just remembered, you guys are going to be allowed 2 pages front and back for your final exam. Okay. No computers looking at different websites to get notes. No, like, you're going to have a piece of paper, 2 pieces of paper maximum, with notes front and back. All right, so if you want to start on that now and start kind of looking at what you have to do and what you have to know, go ahead. I would probably recommend you wait till we do the review, because then on the review, you'll be able to see what you know and what you don't know, and you know what to focus on. So are we okay with division by a single term? Right, how to break it up, right, and then just simplify as best you can. All right, and remember, these are just some tricks. The things in blue right here, those are some algebra 1 skills that you're going to probably have to know how to do. But remember what I told you guys. At first, the first 3 problems you're going to get, they're going to be pretty straightforward, nothing too difficult. But then you get questions like question number 4, right? And questions 5 and 6, right? And if we look, I think you have 9 problems total. Yeah, you have 9 problems total. So when you're doing these things, you're going to have to learn a different way to do it. That's called long division. So let's kind of get into this. I'll try doing maybe 2 or 3 of these things for you guys. Hopefully we can do 3. We'll start off with, let's try number 5, and then we'll go to 6. Okay? Now, I'm going to have to rewrite these on the side because the amount of work that you're going to do sometimes takes a while. So let me kind of rewrite this problem on the side. Okay, so for number 5, so 9k squared plus 9k plus 3. So let me put that over here. Number 5. 9k squared plus 9k plus 3 divided by 3k plus 1 So this is how you're supposed to do these problems. Now notice, I'm not dividing by a single term anymore. I'm dividing by a binomial. Once you get that binomial there, you have to do this a different way. We call it long division because it looks like an original division problem. Okay? You're going to take the first term, 9k squared plus 9k plus 3, and you're going to put that right here. And then the division part, 3k plus 1, you're going to put it outside. Now, you're going to do this just the way you would have done normal division. Okay? Let me remind you of what that looks like. I know it's going to seem like why are we doing this? But just so you can remember what you used to do. So, if I were to tell you that I want you to divide 5 into 63. Okay, if I were to tell you to do it, let's do that really quick. Okay, I know this is like, you're probably thinking, this child's play, why are we doing this? But I'm just trying to show you something. Normally, you would say, how many times does 5 go into 6? Right? And you'd say, okay, 5 goes into 6 one time. Right? Now, what you would do at that point is you would say, okay, what is 1 times 5? 1 times 5 is 5. So you would put that down there. Right? You would multiply and place it. What would you do with those two numbers? You would subtract. Okay, so remember, we subtract. And I got a 1. What would you do next? You would drop your 3. I know this, you're kind of saying, I already know how to do this. We're going to do the exact same steps when we do long division. We drop that 3, and then the next question we ask ourselves is, how many times does 5 go into 13? The answer to that would be what? 2. So let's put a 2 right here. And then we say, what is 5 times 2? Well, that's 10. If we subtract again, my answer comes out to 3. Now, there's no other number. So, you know, in elementary school, you were supposed to write your answer is 12, remainder 3. You guys remember doing that? All right, well, that's the way they wanted you to write your remainders. You put an R. But when you get into high school, they're like, nope, it's 12 plus, and then you're going to get this number, 3, and this number, and you write it out like that, 3 over 5. Your remainder is 3 out of the 5. Okay? And that's how you would write your answer, 12 plus 3/5, or 12 and 3/5 if you want to write it that way. But 12 plus your remainder. Okay? We're going to do the exact same process in long division. Okay? So check this out. You're going to focus on the first. Okay? That's what I usually tell people. Focus on the first terms you see. So 3k and 3k squared. How many times does 3k go into 9k squared? Well, not just 3, but the 3 is part of it. So 3 times 3 is 9. K times what is k squared? K. So 3k, right? So 3k times 3k would be 9k squared. So all we're going to do, like we did before, I will erase this, by the way, these lines, eventually. But I got to multiply 3k times 3k plus 1. I'm going to have to distribute it. Okay? So it's going to multiply to both. So let's see. 3k times 3k, that's 9k squared. 3k times 1 is 3k. And we're going to subtract, just like you're supposed to, right? You're supposed to subtract. Now, 9k squared minus 9k squared, that becomes 0. 9k minus 3k, that's 6k. And what are you supposed to do after this step? What did we do over here when we got a 5? Right here in this step. We dropped, right? So let's drop the next term. Plus 3. Okay, so now I have 6k plus 3. So, focus on the first terms that we see. So here we go. Let me erase that red line. I'm going to go over here. 3k has to become 6k. What do I multiply it by? 3k has to become 6k. What do I multiply by? Someone said it. Go ahead. But well, not k, but just 2, right? Let me change that color. A positive 2. We're going to multiply this by a positive 2. So 2 times 6k, 2 times 3k is 6k. And 2 times 1 is 2. And I'm going to subtract. So 6k minus 6k is 0. That's supposed to happen, by the way. Your first term should cancel. If they don't, something's wrong. Okay? And then 3 minus 2 is 1. Is there anything else for me to drop? No, right? I ran out of terms. So I'm done. So what's my answer? Well, here we go. This 3k plus 2 is my solution, but I have a remainder. Okay, I have a remainder of 1. And remember, you have to divide that 1 by this thing that you're dividing by. So here's your answer, okay? 3k plus 2, that's my quotient. And then that's a positive 1, so plus 1 over 3k plus 1. This is my solution to that problem. You see why they call these long division? Okay, because it takes a long time. Okay, it's not as quick as the one where you just kind of simplify real quickly. Right? It does take some time to do it. And like I said, we'll do more of these. We'll do like 2 more. I have enough time to get 2 more done, I'm pretty sure. All right, that way you're not stuck doing like 8 of these all by yourself. You might have to do like 4. So if I could just kind of walk you through it really quick, just one more time. Looking at the very beginning, we were getting 9k squared plus 9k plus 3, and we were dividing it by 3k plus 1. I asked you guys, 3k times what is 9k squared? We said 3k. So when I multiplied 3k times 3k plus 1, I ended up with 9k squared plus 3k. So I subtract. Upon subtracting, I got 6k, and we dropped the plus 3. So then we asked ourselves, remember, focus on the first, right? That's kind of like the thing I always tell people, focus on the firsts. 3k has to become 6k. All right? How do we do that? Well, we multiply it by 2, right? A plus 2. So I multiplied a positive 2 times 3k plus 1. I got 6k plus 2. We subtract. Notice our first terms cancel out as they should. 3 minus 2 is 1. 1 is my remainder. Now, again, in elementary school, you probably would have written 3k plus 2 remainder 1. But the way they want you to do it now is to put, if this was a negative number, you put minus. If this is positive, you put plus. So for us, it was a plus. The remainder over what you're dividing by, 3k plus 1. Okay? So that would be our answer for question number 5. All right, so let's try something that looks a little bit tougher than that. Notice question 6 and number 8. They have more terms, so we'll go over those. So we'll try 6 and 8. So let me write down question number 6. The number 8 seems to be like the longest one, so that one's going to probably be a really long answer. So number 6, what is it? 3 And right now I'll zoom in on it. I'm just trying to see the question so I can write it out. All right, so this is question number 6. Again, I know the lesson's going to go a little long, but remember, I'm not teaching you guys new stuff so much as I'm kind of just working on homework with you guys, right? So hopefully you don't mind. Let's rewrite this in the proper form. So 3n cubed plus 8n squared minus 5n minus 9. And I'm going to put a 3n plus 2. And remember, I'm going to focus on the first terms, 3n and 3n cubed, at least for that line, 3n and 3n cubed. So I need 3n to become 3n cubed. What should I multiply 3n by in order to get 3n cubed? I want this to become that. What do I multiply it by? 3n times what is 3n cubed? Say it again. Someone said it. Oh, I think I heard you say it. I heard a squared. Did anybody say that? Something squared? I could have swore I heard that. You're going to multiply by n squared. Okay? You're going to multiply by n squared. So 3n times n squared is 3n cubed. And n squared times 2 is a positive 2n squared. And let's subtract. So the first term becomes 0. That's perfect. 8n squared minus 2n squared is 6n squared. And we get to drop our next term, minus 5n. Okay? Just like we did the first time, we're going to focus on the first term. So I'm going to underline 6n squared. Now I need 3n to become 6n squared. What do I multiply by? A 3 has to become a 6, so I multiply by, okay, 2 and then n. Yeah, so I'm going to multiply by 2n. Perfect. So I'm going to get that 2n, and I'm going to multiply those two terms up there. So 2n times 3n is 6n squared, and 2n times 2 is a positive 4n, and I'm going to subtract. Notice my first terms cancel out, as they should. Okay? So all I have to do is negative 5n minus 4n. That's a negative 9n. And I'm going to drop the minus 9. All right, we're almost done. Again, this is why they call this long division, because it can take long. Okay? So last one. Let me erase the other red line here. 3n has to become negative 9n. What do I multiply by? So a 3 has to become a negative 9. Negative 3, thank you. And I'm going to multiply that, negative 3, times these two terms. So negative 3 times 3n is negative 9n. Negative 3 times 2 is negative 6. And I'm going to subtract. So negative 9n minus a negative 9n goes to 0. Negative 9 minus a negative 6, well, it's really a plus 6, so you get a negative 3. Now we're done. We just got to write our answer. So let me zoom out just a bit. My answer is n squared plus 2n minus 3. That's because that's my quotient up here, okay? And then I got to write my remainder, which is a negative 3 divided by whatever we were dividing by, which is 3n plus 2. And that's my answer. Okay? Like I said, I wanted to do 2 with you guys. Well, one more after this one. So we're going to do that one more. And it's the longest one on the homework, okay? So it'll have one more step than this one did. But that way we can kind of get those really long problems out of the way. I know on your final they're not going to be like really long, so it's okay. Any questions on this one? It takes time. Organize your work, line up your numbers, okay? Make sure that you're not like writing things all over the place. Organize the work that you have. So let's look at I forgot what number it was. Number 8. So let me zoom out so I can write number 8 really quick. And then I'll zoom back in. So x to the 4th plus 3x cubed plus 5x squared plus 2x minus 1 divided by x plus 1. So here's number 8. The rest of the problems in the homework are shorter than that. Okay, we did 2 of the longer ones. The one we just did was pretty long. This is the longest one. Number 9 is, I think, just 2 terms dividing by 2 terms. So that was pretty quick. So here we go. Let's set this up. All right, so we got x to the 4th plus 3x cubed plus 5x squared plus 2x minus 1, and on the outside, x plus 1. Now, as bad as this one looks, it's actually not that hard because the binomial that we're dividing by x plus 1 is pretty easy. There's no number in front of the x. It's just an x plus 1. So that's kind of nice. So focus on our first terms, x and x to the 4th. What do I multiply x by to get x to the 4th? X cubed. Thank you. So x cubed. And remember, I'm going to multiply both terms. So let's see, x cubed times x is x to the 4th. X cubed times 1, that's x cubed. And let's subtract. Notice my first terms will cancel out, right? X to the 4th minus x to the 4th is 0. Then I get 3x cubed minus x cubed. Well, that's 2x cubed. And drop your next term. So plus 5x squared. So focus on the first terms again. X has to become 2x cubed. X has to become 2x cubed. What do I multiply x by in order for it to become 2x cubed? Think about that. X times what is 2x? All right, good. 2x squared. Positive 2x squared. Let's multiply that in. Notice I just draw the arrows. You guys don't have to do that. I'm just doing it for a visual so you can see what I'm doing. So 2x squared times x, that's 2x cubed. 2x squared times 1 is a positive 2x squared. And we're going to go ahead and subtract again. Like I said, the first term should cancel out, right? So we have 2x cubed minus 2x cubed, that's 0. 5x squared minus 2x squared, that's 3x squared. And we drop the positive 2x. Again, we're doing the longest problem. Okay, so we're still going to have to eventually drop that minus 1 at the very end. Okay, so we're almost there. So focus on your first terms, okay? Focus on the first. So x has to become 3x squared. What do I multiply x by to get 3x squared? 3x. Good. So positive 3x. Let's multiply both of those terms. So 3x times x is 3x squared. And 3x times 1 is 3x. And we're going to subtract. Almost done, okay? 3x squared minus 3x squared is 0. 2x minus 3x is negative x. And drop the negative 1. Okay, so now we're on the final step here. So x has to become negative x. What did I multiply by? Negative 1. Thank you. So minus 1 up here. So I'm going to multiply these things by negative 1. Okay, so negative 1 times x is negative x. Negative 1 times 1 is negative 1. If I subtract, it all cancels out. That just means there's no remainder. You didn't do anything wrong. That just means there's no remainder, no extra. That means our answer is just the quotient, this big part up here. Okay, that's going to be our answer. There's not going to be any remainder. So I'm just going to write x cubed plus 2x squared plus 3x minus 1. I like putting them in parentheses. You do not have to, okay? That's just my habit, okay? But there's your answer. So this is what you guys have for homework.